Okay, so in this video we're going to go over the periodic table. Okay, so we're going to use a question that came in 2020 paper 2 science, that is chemistry, that is paper 2, that is course certificate. Alright, so the first question that came is like we are given a table of elements. We have been given lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, and neon. Okay, then the first question is asking us to say to which period of the periodic table do these elements belong. Right, so before even dive into answering this question, we need to familiarize ourselves with the periodic table. And yeah, so when you're talking about periods, so we have these two words, periods, as well as what, as well as groups. So now, how do we differentiate these two people? Right, so in talking about periods, we call them what? They are horizontal rows. These are periods. Then we're talking about groups, they are vertical. They are in this manner. So meaning when you're counting in this manner, say 1, 2, 3, these are what? Periods. When you're counting as 1, 2, 3 going this side, these are what? Groups. So now it's just a matter of now going to the periodic table to find out where we are going to find lithium, beryllium, boron, carbon, nitrogen, oxygen, so on and so forth. And according to the my periodic table, it's telling me to say those are in what? Period 2. So I can say those are in what? Period 2. Those are in period 2. Okay, so now that question was very easy to answer. Let's go to the second one. We say what happens to the number of shells across what happens to the number of shells across the period shown above? So the question is asking us to say, are the number of shells going to increase as you go across the period, or are they going to reduce as you go across the period, or are they going to increase? So we're talking about three possibilities here. The first one is that say first, say second here, third. So talking about three possibilities. So as you go this side, are they increasing? As you go the other side, are the number of shells increasing? Say increasing, or we say reducing. Or we say what? Constant. Constant meaning they still remain the same. If there's 2, meaning 2. If there's 3, meaning 3. So that is what the question is asking us. That is the question is asking of us. So now it's very, very important to understand how electrons are filled up in shells of atoms. Okay, so now let's pick 2. We can pick the first one. We can pick lithium, or let me say we pick 3. We can pick lithium. We pick also what? We pick oxygen. Carbon. We can also pick oxygen if we like. So when you go to the periodic table, lithium has an atomic number of what? Atomic number of 3. Okay, and please don't worry. You find that some periodic table is down, the atomic number, some periodic table is up. It doesn't really matter that much. Okay, so when you go to carbon, carbon has an atomic number of 6. I'm leaving out the mass numbers. We're just talking about the atomic numbers because they are the ones that are going to help us determine the number of shells that we are going to have. Alright, so we have also picked what? Oxygen. Oxygen has an atomic number of what? 8. Maybe to spice up things, we can also pick neon, which is what? A noble gas, an innate gas, meaning it's non-reactive. It already has a 4 atmos what? Energy level. Neon. So neon has an atomic number of what? 10. So now, if we write the electronic configuration of what? Of lithium, what you have is something like this. You're going to have a 2, what? A 1. Okay, when you go to carbon, you're going to have 2, what? 4 as the remainder. When you go to what? Oxygen, you're going to have a 2, what? 6. when you go to neon, you're going to have 2 comma what, comma 8. So you have seen to say these, we have 1 2 here, 1 2 1 2 1 2, so meaning the number of shells remains the same. The only thing that is increasing here, if you have observed, is the number of variance electrons. So meaning it's increasing by what, by 3. We are adding 3 to a 1 to get 4. We add a 3 to a 1, we get a what, we get a 4. On the other side here, we added a 2 to get what, a 6. So all the same. So the only thing that was increasing in this case is the number of what, the number of valence electrons, but the number of shells was not increasing. So if you asked to say what happens to the number of valence electrons, it was increasing, but the number of shells remained the same. Okay, so here we say remains the same. Remains the same. Or I don't know which language, which how you can put it in different ways, but the only way that is coming out is what, is constant. Then it's not changing. So we go to question C. It says answer the following questions using only the elements shown in the table above, which is B4.1. Each element can be used once, more than once, or not at all. So now the first question says which two elements would form an ionic compound. So when you're talking about ionic, whenever the word ionic comes in, ionic, let's just say, I know without even saying ionic compound, let's just talk about what, ionic itself, this word ionic. So talking about ionic, this is related to what, ionic bonding. Takes us to what, chemical bonding. So talking about ionic bonding, just talking about what should ring first is what we're talking about, what, metals and what, non-metals. So basically we're just talking about two that can give us what, an ionic compound. All right, so we can pick one from these two metals that we have. We have the lithium. The lithium there is a what, is a metal, and we also have what, beryllium is also a metal there. So that is what the question is just basically asking for. So which element has a valence? The second question is which element has a valence of what? A valence of 3. So what does it mean? A valence of 3, we're just talking about number of valence electrons that we have. Okay, didn't mean to rub that. Just remove this part. Okay, so which element, we have as to say which element has a valence of what? Valence of 3. So we are talking about one that has 3 electrons in the outermost energy level. And when you look at lithium, we say we found that it had what? It had 1. When you go to when you go to beryllium, not boron, but beryllium, it has what? Has a 4 atomic number, meaning it has what? 2 comma what? 2 comma 2. Right, then you go to what? To boron. Boron is in group 3. Okay, it's just after the transition metals. It's in group 3, and boron has a what? Boron has the valence of what? 5, meaning the electronic configuration is what? 2 comma what? 2,3, and that is what we are looking for. So immediately you are able to do this, then you are safe, very much safe. So the last question is saying which element has allotropes. So we're talking about allotropes in this case. We're just talking about a different form of any element that you can be given. Okay, so in this case you're talking about what? Carbon. It can be graphite, it can be a diamond, so on and so forth. Yeah, so that's how simple that question was. So basically here we're talking about what? Carbon. Here we're talking about what? Boron. Okay, here we can pick from those metals that we have on the list. Yeah, so that's how we go about answering that question. Thank you.